All right, let's dive in. Today, we're talking about that amazing aha moment. How we go from feeling totally stuck and confused to actually mastering something new. We're going to break down the science behind it. You know the feeling, right? You're staring at a new piece of code, or maybe a math problem, or heck, even those furniture assembly instructions, and your brain just hits a wall. It's like a total mental traffic jam, and absolutely nothing seems to get through. Well, that super frustrating, I'm stuck feeling, it's not just you being bad at something. Turns out, science has a name for it: cognitive overload. And the first step to beating it is to actually understand what's going on inside our heads. See, when you're a beginner, your brain is trying to do everything at the same time. You're trying to figure out the goal, invent a strategy from thin air, and on top of all that, you're desperately trying not to mess up. It's no wonder our working memory just throws its hands up and says, "Nope, I'm done." But here is the really good news. This is not some impossible problem. There's actually a proven roadmap that can guide a brain from that point of complete overload all the way to mastery. And the whole thing starts with one surprisingly simple but incredibly powerful idea. And that idea, it's all about harnessing the power of a perfect example. Now, we're not talking about just any old example here. We're talking about something very specific called a worked example. And the key difference is all in the details. It's a full step-by-step demonstration of the entire thought process, from the very beginning to the very end. And this is such a common mix-up. Just showing someone the final correct answer, that is not a worked example. That's kind of like showing someone a picture of a beautiful cake and then just expecting them to know the recipe. A true worked example is the recipe. So what goes into that recipe? Well, a true worked example shows every single step. It also includes the expert's reasoning, often through something called a think aloud, where they literally talk through their decisions as they make them. It even points out the common mistakes to avoid, and this is crucial. It makes the whole process something you can use on other similar problems. And this is exactly why it's so powerful. It takes away that huge burden of what do I even do next, and lets the learner focus all of their mental energy on understanding the how and the why. It's a total game changer for cutting through that cognitive overload. Okay, so a great example gives you the map, but how do you actually start walking the path yourself? This is where we build the bridge from just watching to actually doing. Let's think about learning to ride a bike for a second. The map, knowing where you want to go, is important, sure, but it's those training wheels that give you the confidence to start pedaling without face planting. Learning a new skill is pretty much the exact same thing. In learning science, those training wheels have a formal name. They're called scaffolds. And just like with a bike, they're temporary supports. They're designed to hold you up just enough so you can practice successfully, building your skill and your confidence at the same time. And you've definitely seen scaffolds like these all over the place. They can be simple things, like checklists or step-by-step lists, or maybe partially completed problems that just get you started. Even things like sentence starters or word banks, they're all just tools designed to make it easier to start practicing. This whole journey from needing tons of support to needing none at all follows a really clear path. It starts with I do, where the expert shows you how. Then it moves to we do, where you practice with those scaffolds for support. And here's the critical bit. That support is gradually taken away. That's a process called fading, until finally the learner is at you do, tackling the whole thing by themselves. Which brings us to what is really the art and the science of teaching. Because knowing when to take those training wheels off is every bit as important as putting them on in the first place. I mean, really think about it. What happens if you never, ever take the training wheels off a kid's bike? Do they ever really learn how to balance on their own? The answer is, of course not. The very thing that was so helpful in the beginning becomes a crutch. It actually stops the learner from developing that core skill, in this case, balance, or, for our purposes, true independent mastery. And get this, there's actually a scientific name for this too. It's called the expertise reversal effect. It's that tipping point where the help that was so useful for a beginner actually starts to get in the way and slows down someone who's getting better. They have to process the task and the unnecessary help, which ironically adds back that cognitive load we tried to get rid of. So, how in the world do you know when it's time to pull back? Well, it's not just a gut feeling. Research points to a really solid benchmark. When a learner is getting things right about 80% of the time with the support, that's a huge signal that they're probably ready to try with less. And beyond just that number, there are other signs you can look for. Can they explain the process back to you? Are they asking for fewer hints? And here's the big one. Are they starting to catch and fix their own mistakes? All of these are just green lights flashing, saying it's time to start fading that support. So let's pull all of these ideas together now and look at the whole picture, the complete system for building a skill that actually lasts. This table really lays out the entire journey perfectly. You start as a novice, right? The teacher's job is just to provide great models, and the learner's only goal is to understand the process. Then, as you start developing, the teacher offers those scaffolds to help you practice. And finally, to become truly independent, the teacher has to fade that support away, which is what allows the learner to build real, lasting mastery. And this, right here, is the ultimate goal of it all. The point of the worked examples, the scaffolds, the fading, it's not just about getting one task right. It's about building a flexible, powerful mental model inside the learner's head, a model they can take with them and apply to any new challenge that comes their way. So I'll leave you with this to think about. Look at your own life, your job, your hobbies, even the way you help other people learn. Is there a training wheel still attached somewhere? A checklist you always lean on? A template you never deviate from? What might happen if you finally decided to take it off?